rarely used technique to upgrade old power lines could play a major role in expanding the U.S. power grid. The method is called advanced reconductoring, and a couple of recent reports suggest the concept could roughly double the capacity of the electric grid in many parts of the country. Joining us now to discuss is one of the lead researchers who compiled the data showcasing the benefits of using this technology, Umed Paliwal, senior scientist at the University of California, Berkeley. Can you tell me more about advanced reconductoring and what your research has been telling you?
Yeah, thank you for having me here. So essentially, reconductoring is essentially replacing the wires of an existing power line with newer wires that are made up of advanced materials. Now these newer wires are able to carry double the amount of electricity as compared to the conventional wires. And the reason this is so important today, because the US is seeing an unprecedented growth in the electricity demand. We are getting new manufacturing facilities set up in the US. A lot of data centers are coming in the US, and more consumers are buying electric vehicles. All these users need a reliable supply of electricity. So the solution that we are coming up is that of reconductoring, that we can just replace the wires of the existing transmission line. And the interesting thing about this is that this could be done in 1 to 2 years as compared to building new transmission lines, which takes 10 plus years. So that way, the electricity demand that is coming up today, in 1 to 2 years, we could supply that electricity reliably through just changing the wires of existing transmission lines.
What exactly is the difference between the current power lines that we're using versus if we were to put these advanced reconductoring wires in?
So in these newer wires, what we do is we replace the steel with a material that is made up of carbon fiber. And carbon fiber is 10 times as stronger as steel, and it doesn't sag when it's heated. The conventional wires that are used today, they are made up of aluminum and steel. It's a century-old technology that has not been updated so far. And what happens is, as you send more and more electricity through these wires, they heat up. And as we have studied in our physics classes, if something heats up, they expand. And as these conventional wires, they heat up, they expand and they sag. And what happens then, if they sag, they can come in contact with vegetation, and that could be a safety hazard. So if we send more and more electricity through these advanced wires, they don't sag, and that's why we can send more electricity through these wires as compared to the conventional wires.
So how big of an increase in capacity does advanced reconductoring provide? I know you mentioned 2 times, but is that the peak? We could get up to 2 times, but it might be less?
Yeah, so what we found in our study is that by 2035, if we adopt reconductoring, we can add 4 times as much new transmission capacity as otherwise if you would have just relied on the conventional wires. So the electricity is the foundation of our modern economy, and supply of cheap and reliable electricity builds the industrial base. And if we have to compete globally, that is a requirement. If we want the AI revolution to happen in the US as compared to somewhere else, we need to build this infrastructure.
Are there any environmental concerns tied to building these advanced wires?
Yeah, so there are, so these wires, the raw material that is used to build these wires is a byproduct of the oil refining process. So there are some carbon emissions that are associated with it. But what is again interesting is these advanced wires, they have half as much as electrical losses as compared to conventional wires. Just give you a perspective, last year we lost about 5% of the electricity, and that is equivalent to the total amount of electricity that was generated in the state of California.
But what about the everyday American? Will it save them on their utility bill?
Yeah, so what we found is that by 2050, the electricity cost to the consumers will reduced by 3 to 4% because of these advanced wires. And by 2035, we estimate that the consumers would save $85 billion, and by 2050, the consumers would save $180 billion, if we adopt reconductoring.
Where do you see this going in the future?
Yeah, so the utilities, they are a conservative industry. They tend to do what was done last year and so on last year. So slowly, a lot of utilities are waking up to this opportunity. I mean, it is kind of like important for them to adopt this technology because it takes 10 to 15 years to build these new transmission line. And this solution is much faster and costs half as much as building new lines.
Well, Umad Paliwal, senior scientist at the University of California, Berkeley, thank you so much for coming on and telling us about this incredible venture that you are a part of.
Yeah, thank you for having me.
Coming up, global leaders are teaming up in an effort to combat plastic pollution. Stay tuned. That story is just ahead on EarthX News.